So a ratio generally has no units. And a simplified ratio uses only whole numbers. So if we want to simplify a ratio, it's more or less like simplifying a fraction. You just have to divide each side by the same number until you reach the point where you can't divide anymore. So here they've got an example of 15 to 20. The 20 divided by 5 gives us 4, and the 15 divided by 5 gives us 3. So, and then we can't divide it up anymore. So there's a few examples over here. Over here, I just want to stop quickly. And this one has 2 kilograms and 400 grams. The first thing we want to do if we want to work in a ratio is we need to make the units the same, if possible. So we convert the 2 kilograms to 2,000 grams, and then we can start dividing and get our actual ratio. Okay. Over here, we start with a decimal number. So the first thing we need to do is multiply in order to get rid of the decimal. So we multiply by 10 here to make it 32, and then we can start dividing to simplify the ratio. Okay, so the next part is sharing things in a ratio. So here we've got James and Elaine are sharing a box of sweets in the ratio 2 to 3. So the first thing you have to do is you have to add these together. So we have 2 plus 3 gives us 5. So that means that there are 5 parts we need to divide this into. So that means that James gets 2 parts out of 5 and Helen gets 3 parts out of 5. So I will do a few examples of this in a second. I just want to finish this part of the page and then we will do the examples. Okay, so if we turn things into a ratio 1 to n or n to 1, that makes it very easy for us to compare different kinds of quantities with each other, especially if we've got things in different ratios. So here we can divide these by 4 to reach 1 to 3. Here we have to divide this side by 1 by 2, this side by 2, and then we get 4.5. So here we've got 4.5 to 1. We use this specific thing if we want to compare quantities because it makes it a lot easier. Say if you want to compare the amount of flour and butter in a recipe, then you can then divide it out until you've got both of them compared to the same thing, and then you can very easily see which one you have more of. Okay, so there's a few examples of dividing into a ratio. So here we go, dividing into a ratio. Here we've got 36 pounds that they want us to divide into the ratio of 3 to 5. So the first thing we do is we add those together. 3 plus 5 gives us 8. So now we need to take this 36 and divide it by 8, which gives us 4.5. Whoops. There we go. So now you guys should really stop moving around the teacher's cam. And actually, yeah. But okay. So anyway, so we get 4.5. So now we know how much is in each part. So that one is in each part. So now we have to know that this needs to be divided into the ratio 3 to 5. So the first thing is we need 3 parts on this side. So we times that by 3. So we have 3 times 4.5, which gives us 13.5 on the one side. and we have 5 times 4.5, which gives us 22.5 on the other side. If we add these two together, we should be getting 36. So 0.5, 0.5, that gives us 1. That's 3, 3, 6. Yes, that works. So we haven't made a mistake. Okay. So now we've worked out how much each is. So we have in pounds, £13.50 and £22.50 that we divided it into. So I'm going to pause here for a bit and let you guys try this one. So 78 pounds divided into the ratio of 5 to 7. Okay, you can now only chat to me. So please type in your answer for this question. You have 1.5 minutes to 2 minutes, so please try it. Okay, so we're dividing something into a ratio. Here we have 78 pounds that we want to divide into the ratio 5 to 7. Here we just did it for 36 pounds in the ratio 3 to 5. So please try it, and then let's see what you guys come up with. You can type your answers to that into the chat. Let me start with this one. See if you guys got it right. So we want to divide 78. We first have to add the 5 and the 7 to see how many parts we have. That gives us 12. So now we need to divide this 78 by 12. So 78 divided by 12 gives us 6.5. So now we need to take this 6.5 and we need to times it by 5 and times it by 7. So we've got 5 times our 6.5, which gives us 32.5. And we have our 7 times our 6.5, which gives us 45.5. So our answer then is we've got £32.50 and we have £45.50. Okay. So I will come do a few more of these if we've got some time at the end of the lesson, but we need to move on. So now we've got another question here. So this table shows the ratio of teachers to pupils needed for some activities at a school trip. So if there are 5 teachers to take the pupils climbing, what's the greatest number of children that can go climbing? So first we need to go find the ratio for climbing. So that gives us 1 teacher to 4 pupils. So we have 1 to 4. There's our ratio that we need to work with. So now we need to get this side of the ratio to 5. So we have to times by 5 on this side. And what we do on the one side, we do on the other. So we times by 5 on this side, which gives us 20. So if we have 5 teachers, we can have a maximum of 20 students. The answer there is 20 children. Okay. So now you guys get to try this one. 23 pupils want to go walking. What is the smallest number of teachers that are needed to take them walking? So I'm just going to help you quickly. For walking, our ratio is 1 to 11. So 1 teacher for 11 students. Okay. You have a bit of time, so quickly try it and give me the answer in the chat and we'll see how you do. If you can't see the ratio, I did go look it up over here. So we've got walking 1 to 11. So there's our 1 to 11 over there. So how we can do this one, we want the smallest number of teachers needed. So 23 is not a multiple of 11. So we want to get something that 23 is in between. So if we multiply this side by 2 and this side by 2, then we get 2 to 22. So 2 teachers for 22 students. And if we do the same with 3, we get 3 to 33. So our 23 students lie somewhere between 22 and 33. So we will need at least 3 teachers. I'm going to have you guys try this one. So 15 pupils want to go cycling. How many teachers are needed? So let's go look up what we have. Cycling, we've got the ratio 3 to 9. So we have 3 to 9. So 3 teachers for 9 students. Okay, so the first thing we need to do here is this isn't in its most basic form. So we need to go get it into its most basic form. So we can divide both sides by 3. So if we divide by 3 on this side, we get 1. Divide by 3 on this side, we get 3. So that makes it very easy. So now we need to turn this side into 15 because we want 15 pupils. So that means we have to times it by 5. So we times it by 5 on that side, which means we have to times it by 5 on this side. So we will need 5 teachers. Okay. So I'm going to skip these and go on to our next section, which is value for money. This is a very easy way of using proportion and ratio in order to help you in your very daily life. So this is where you can compare the price of 2 differently sized products. It's the same product. They're both bubble bath in this case, but they come at different prices and they've got different amounts in them. So there's a bunch of different ways that we can work with this. The first 2 ways has to do with the quantity. So the first way is to make the smaller size up to the larger size, the quantity of the product. And the second way is to turn both into the same quantity. So here, we want to get 250, so we'll have to multiply this by 2.5 in order to get the small bottle up to 250. And if we do that, we need to multiply our price over there by 2.5 as well. So that's what they're doing here. And then they get £4.13 for that bottle. So now we've got them in comparable quantities. So this one is for 250 mils as well. So now we can compare the prices. This one is £4.13 and that one is £4.15. So this one will obviously then be better. So our second method is to find the smallest common multiplier. So we can turn both of these quantities into 500. We need to times the 100 mils by 5 and the 250 by 2. So that's what they do here. There's the 100 mils times by 5 to get £8.25. And there's the 250 mils times by 2 to get £8.30. So then we can see that this one is easily the best value for money. So our last 2 methods is to get the price per pound, or the amount that you get per pound. So here they've worked out for 1 cent how much milliliters can you get. You can do the same by getting it for 1 pound. So how you do this is you would take your price here. So we've got 100 mils for £1.65. So we've got 100 mils to £1.65. So what we then do is we divide by 1.65 on this side and on this side as well, which will give us our amount of milliliters per pound. And that will then give us a comparable value for both sides. So here they get the price for 1 milliliter on each side. So this is what I meant with the 1:n ratios that we had over going up. Here, 1:n and n:1 ratios makes it very easy to compare things. So if we look at our bottles here, both of these two methods compares 1:n or n:1. So if we get both of them into the same format, then we can compare them. So in order to get this one, we will have to divide this by 1.65 in order to get 1. Something happened. And the other side will also then have to be divided by 1.65. Okay. The trick here, if you're working with 1:n's, is to keep your units on both sides so that you know what values you are comparing. So now we're going to do another example. So if someone pays £35.60 for 40 songs, and then in April she pays 5p more. So first, we don't know what exactly she pays for the songs, so we need to first go work that out. So we have £35.60 and for 40 songs. So we need to go divide by 40 over here in order to get the price per song. So if we do that, then we get 0.89 pounds per song. Sorry, my 9 looks terrifying there. So that was then. Now in April, she pays 5 pence more. So that means we have to add 5. So now she will pay 0.94 per song. So this is our pounds and this is our songs. So now we can work out if she has a £30 voucher, how many songs can she get? So we take our £30 voucher and we can divide it then by our 0.94, which will give us 31.91 songs. So she can get at maximum 31 songs. Okay. So here you guys go. I want you guys to try this example. So here you have to compare the prices of 2 different years worth of electricity. So in 2012, electricity cost 50 pence per unit, and a family used 3,729. And then a year later, it got more expensive, but they used less. So we want to figure out how much more the family paid for electricity in 2013. So price in 2012 and the price in 2013, how much they paid, the total amount they paid and the total amount they paid. And then we can subtract them from each other. So please put your answers for how much they paid in total in 2012 and in 2013 in the chat, and we'll see how you guys are doing. Here we have 2 different years. We've got the price of electricity in 2012 and the price of electricity in 2013. So here it costs 15p per unit, and the family used 3,729 units. So we have 3,729, and it costs 15 pence per unit. So we have 0.15 pounds. So that gives us an answer of they spent £559.35 on electricity in 2012. So now we do the same for 2013. They spent, they used 3,506 units. at 17p. So that gives us so that gives us a total of £596 and 2 cents. So how much more did the family pay for electricity? We take that, we minus that, and our answer is then they paid £36.67 more. Okay. So we've got about a minute left, so I'm quickly going to go through map scales. So if you've ever seen a map, then you get this little scale, 1 to 100,000, 1 to 50,000, something in the corner. If you go onto Google Maps, you can see this scale. They've got it probably down in this corner or this corner, depending. So what this means is that if we have 1 centimeter on the map, it is 100,000 centimeters in real life. So if you want to go compare distances, you can take your 1 centimeter, but this you will then have to convert into kilometers or meters so that you can actually see what you are looking at. So this is also a very practical example of what we use ratios for. Okay, and that is pretty much it for today. So I will give all of these to Richard so that he can give it all to you if you ask for it. So thank you for coming. And I will most probably not see you next week because it'll be Richard's lesson again.